All right, we have a box resting on a table. Now, we've done this problem before, but I just wanted to make sure that we're kind of practicing properly. So we're going to have a normal force and a weight, and those are the forces acting on it. Now, when we push this box off the table, you're not required to do this, but just know that once it's actually falling, this is Fg. And we want to know its speed when it hits the ground. So a lot of ways we can do this. I like to actually draw a picture, so I would actually put x naught as 2 meters here. We'll make the ground elevation 0. Its speed here is 0. At the bottom, it's unknown. We don't know the time. And since this is the direction it's falling, and we're calling this the positive, going upwards is positive, but it's falling down, we'll say the acceleration is negative 10 meters per second squared because that's gravity. Now, since we don't have time, the formula I want to pick is probably the one that doesn't have time in it either. So v squared is v naught squared plus 2 times a times x minus x naught. And all I'm going to do is plug in my formulas, plug in my numbers. So v squared is, again, I started at a speed of 0. My acceleration is negative 10 due to the gravity. X here is 2. We have 0. And so we end up getting v squared is actually, this is 40, and that actually is going to give us v equals 6.32 meters per second. All right. Very nice. This is just a great question. Okay, I'm going to just put this out there. For F period, this is extra credit for F period. It is required for G period. So if you are an F period, this is worth like 2 points of extra credit. G period, you need to know this one. This is a great problem. So we want the speed of this thing at the bottom of the valley. So let's be clear. It starts here. Oh my goodness. Let me just try to draw it. I wonder if I can draw a car as well as this graphic from 1997 can. Okay, here we go. Oh, look at that. My goodness. All right, so we got a height h here. Meow. Okay, there we go. mgh equals 1/2 mv squared. I'm just using conservation of energy, right? So I've got all this height here. That's gravitational energy. Then it gets converted into kinetic energy right at the bottom. Don't make it a huge deal. So here I got 200 times 10 times my height, which is 20, equals 1/2 times 200 times v squared. What? Okay, these actually cancel. Isn't that nice? And then I'm going to end up actually getting 400 is v squared. When I square root both sides, I'm going to get 20 meters per second is our speed. Now we want the normal force on the go-kart. To do this, I'm just going to actually follow the directions here. So let's draw the free body diagram. We get a normal force. Woohoo! And then we get the weight, Fg. And what we're saying is those forces make it move in a circle. That's a fancy way of saying Fn minus Fg makes it accelerate with centripetal acceleration. And that's Fn. And here, let's actually put in mg and m v squared over r. Now, look at all these delicious numbers we're going to plug into our formula. We get Fn minus 200 times 10, right? Because g is 10 and m is 200. Equals 200, and then we've got our v of 20 from part A, and then we're going to divide that by our radius of 20 as well. So one of these will actually end up canceling, and just when you work this out, you're going to end up getting 6,000 newtons worth of normal force. It's actually why we feel a little bit heavier at the bottom of hills, because we're being pulled in a circle. Pretty exciting question. So that's the first part of problem 7. Let's just kind of continue here. Look at these waves. Oh my gosh, just craziness. Okay. We have a standing wave on a 2-meter string, and it has a second harmonic with a frequency of 8 hertz. We want to know its speed. So v is lambda times f. Now let's be clear here for part A. It's the second harmonic. So I need to get the wavelength of the second harmonic. So lambda 2 is going to equal 2 times L over n, which is 2 times 2 divided by 2, which is 2 meters. And that's because L is 2 and N is 2, okay? Great, so now let's get the speed. V is going to equal 2 times 8. So V is going to be 16 meters per second. I should have given you a little bit more space to work. I'm sorry. So for B, we want to know the frequency of the fundamental harmonic. All right, so this is all part A. For part B, okay. Well, we know that F2 from above is 8 hertz, which is 2 times F1, because I'm using the formula Fn is n times F1. So this is 2, and that's going to be 2 right there. And this is for part B. So when I actually solve for F1, F1 ends up being 4 hertz. Well, isn't that nice? Then for part C, we want to know the wavelength of the fourth harmonic. Again, just keep it simple. 2 times L over 4 is lambda 4. That's going to be 2. Did I get that right? Okay. 2 times L. Yeah. So that's going to be 2 times 2 divided by 4. And that's giving me 1 meter length for lambda 4. All right. All right. Part 4. This is only for G period. And so let me set up a free body diagram here. For F period, you can get a couple bonus points here. So let's set it up. We got a friction force. Meow. We got tension. We got weight. Okay, but there's more. We've got a normal force pushing up. And let's be clear here. I'm going to have Tx here, which is going to be 30 cosine of 30. And I'm going to have Ty here, which is going to be 30 times the sine of 30. All right. Now, let's go ahead and set up x and y equations. So in the y direction, we're going to say Ty plus normal minus weight equals 0. That's going to be 30 times the sine of 30 plus the normal force minus the weight, which is 3 times 10 mg equals 0. So when I actually work this out, I'm getting a normal force of 15 newtons. Awesome. And in the x direction, we're going to have F in the x direction from the tension. Sorry, that's T. T in the x direction. Minus the friction equals little m times a. So that's going to be 30 cosine of 30 minus the friction, which is 0.2 times the normal force, equals 3 times a. So let's just work that out. So when I actually work this out for a, I'm getting a is 7.67 meters per second squared. You can check my numbers on that. So that is question number 7.